Hello guys, my name is Rishi. I'm studying in Sri Venkateswara College of Engineering. Today we are going to study about support vector machine. These are the topics we are going to study in support vector machine. Introduction to support vector machine, how does it work, SVM parameters, advantages, disadvantages, applications, variations and conclusion. Introduction to SVM. It is a powerful machine learning algorithm used for both classification and regression tasks. It is mostly used in classification problems such as text classification, image classification, and bioinformatics. In SVM algorithm, we plot each data item as a point in n dimension space, wherein where n is the number of features you have, with the value of each feature being the value of particular coordinate. Then we perform classification by finding the optimal hyperplane that differentiates the two classes very well. How does it work? SVM is a binary classifier that separates data into two classes by finding a hyperplane that maximizes the margin between the two classes. The margin is the distance between the hyperplane and the closest data points from each class. SVM can also handle non-linearly separable data by performing the data into a higher dimensional space. Identify the right hyperplane scenario 1. Here we have three hyperplanes A, B and C. Now identify the right hyperplane to classify stars and circles. Select the hyperplane with which segregates the two classes better. In this scenario, hyperplane B has excellently performed this job. Identify the hyperplane 2, scenario 2. Here we have three hyperplanes A, B, C and all segregate the classes well. Now how can we identify the right hyperplane? Here maximizing the distances between the nearest point and the hyperplane will get us to decide the right hyperplane. This distance is called margin. Here you can see the margin for hyperplane C is high as compared both A and B. Hence, we name the right hyperplane as C. Another lightning reason for selecting the hyperplane with uh, with a higher margin is robustness. If we select a hyperplane having a low margin, then there is a high chance of misclassification. In this scenario, we can't have a linear hyperplane between two classes. So, how does SVM classify these two classes? Till now, we have looked only at the hyperplane. SVM can solve both problem easily. It solves this problem by introducing additional features. Here we will add new feature. Now let's plot the data points on axis X and Z. In this plot, points to consider are all values of z are always be positive because z is squared in both x and y. SVM parameters. C is a regularization parameter that controls the trade-off between maximizing the margin and minimizing the classification error. Gamma is a parameter that controls the shape of the decision boundary. High gamma values lead to more complex decision boundaries. Kernel function is a function that transforms the input data into higher dimensional space. Common kernel functions include linear polynomial and radial bias function. Advantages and disadvantages of SVM. Advantages: SVM can handle high dimensional data and large dataset efficiently. SVM is robust to overfitting due to its ability to control the complexity of the decision boundary. SVM can handle non-linearly separable data by using kernel functions. Disadvantages: SVM is sensitive to the choice of kernel function and its parameter. SVM can be computationally expensive for large datasets and complex kernel functions. SVM does not provide probabilistic outputs, which may be necessary for certain applications. Applications of SVM. Image classification. SVM has been used to classify images based on their content, such as detecting objects in images. Text classification. SVM has been used to classify text documents into different categories such as spam, filtering, or sentiment analyzing. Bioinformatics. SVM has been used to classify genes based on their expression patterns or to predict protein-protein interactions. Variants of SVM. One class SVM used for anomaly detection by finding a hyperplane that encloses a single class of data point. Support vector regression used for regression tasks by finding a hyperplane that minimizes the distance between the predicted values and the actual values. Multi-class SVM used for multi-class classification by constructing a multiple hyperplanes to separate the classes. Conclusion: SVM is a powerful machine learning algorithm that can handle high dimensional data and large data sets. SVM can handle non-linearly separable data by using kernel functions. SVM has a variety of applications in fields such as image classification, text classification, and bioinformatics. Thank you.